Okay, so we're still on page 14, taking some notes. So if I told you to simplify the square root of 100 over the square root of 121, every time your directions are going to be simplify, but I'm not going to make you write simplify over and over and over again. Can anybody tell me why this one is so much easier? Go ahead. Because they're both perfect squares. What's the square root of 100? What's the square root of 121? The end, you're done. So if the top and bottom are already perfect squares, then you just take the square root of them. Now, you don't have to write this one and write something in a different color pen. Occasionally, you'll see this written like this. Instead of trying to see if that fraction will simplify or whatever, if you recognize, hey, that top and the bottom are both perfect squares, break it up like this and go ahead and take the perfect squares. Okay? It could be either. So you need, like, it could look like this and you could go straight there, or it could look like this and you'd convert it to this and do that. So you need to be able to recognize both ways, which is why we're going to practice a lot. Yes?
So if they were written like the one that's the green, if we just went straight to the answer, would it be like
that would be fine if you could go ahead and see, hey, both of those are perfect squares, let me just take the square root. But what you're doing in your head is this. But yes, I'd be okay if you went straight from here to here if they're both perfect squares. But you're able to do that because of that middle one right there. All right, now let's do this one. This one is harder than the second one, but easier than the first one. Now, remember how I said there's multiple ways you can do the same problem? When I look at this one, I automatically say, hey, I know that 75 divided by 3 is easy to do. Because I know 3/4 makes 75 cents, right? So what I would do is I would start by putting them under a square root together and say 75 divided by 3 is 25. And what's the square root of 25? 5. But you could start by rationalizing the denominator, which means you would say square root of 3 times square root of 3 on bottom, and whatever you do to the bottom, you must do to the top. You're welcome. Or you could start by breaking 75 down using the factor tree method, and then rationalize the denominator if needed. Either way you do it, you'll still end up with 5. So if I recognize that separately they would divide into be integer or a whole number, I like to start with that first. All right, one more of the ones that's a little difficult, and then you are going to practice them. How exciting. Square root of 8 over square root of 24. See, when you start doing math, you can forget about all your problems and just worry about these problems. Because while these are scary, they're not as bad as real life problems. All right, somebody tell me an option we have. I could put 8 and 24 together because they have something that I can divide them both by to make them common. So we could make this a fraction together and say, hey, 8 over 24, those are both divisible by 8, so that would be 1 over 3. That's not the answer, but that's getting us closer to the answer. Another thing you could have done is you could have took 24 and started breaking it down using the singles mingle, and took 8 and started breaking it down using the singles mingle, and then go from there. You do whatever comes to your brain first. But now I got to finish because we have a rule that says you can't leave a fraction under the square root. So I'm going to break this up into the square root of 1 over the square root of 3. Well, we have another rule that says you can't leave a square root in the denominator. What's the square root of 1? 1. So I can go ahead and write another step where I put 1 over the square root of 3, or I can start rationalizing the denominator. I'm just going to start rationalizing the denominator. So how do I get that square root of 3 out of the bottom? Multiply by the square root of 3. And whatever I do to the bottom, I must do to the top. Well, the square root of 1 times the square root of 3 is just the square root of 3. Because 1 times 3 is 3. And the square root of 3 times the square root of 3 is 3. So then I have to ask myself, have all three things been met that we put on that list on page 4? The first one says everything under the square root can't have any perfect squares left in it. Are there any perfect squares that'll go into 3? Nope. Can't have any fractions under the square root. Do I have a fraction under the square root? Nope. Can't have any square roots in the denominator. Do I have any square roots in the denominator? So I'm done. Once you can check off those 3 things, then you know you're finished. All right, now we're going to go back to page 12, like I was mentioning before. And you are going to try number 13 on your own. Page 12.